Question 4 is a little bit similar. For what values of x does this infinite series converge to 3? Well, it certainly seems as though with every iteration, with every term, I'm multiplying by 3x. So that's my r value. My r value is 3x. In order for this to converge, r has got to be less than 1. So the absolute value of 3x must be less than 1. And we can rewrite this as a compound inequality. So then x is sandwiched between negative 1/3 and 1/3. So the value of x for which this converges, well, we know x has got to be in there. Now let's answer the question. If this is going to converge to 3, then our sum will be 3. So a sub 1 over 1 minus r should be equal to 3. And let's solve that equation. We multiply both sides by 1 minus 3x. We'll be left with 5 is equal to 3 minus 9x, which gives us 2 equals negative 9x, which gives us x is negative 2 over 9. For what value of x does this converge to 2017? Well, 5 over 1 minus 3x then is 2017, which gives us 5 is equal to 1 minus 3x times 2017. I guess I'll distribute this. 5 is equal to 2017 minus 2017 times 3 is 6051. This is going to give us negative 2012 is negative 6051x. So x is going to be 2012 over 6051. To visualize, determine the values of x for which the series will converge. Done that. This is less than 1/3. This is less than 1/3. Find the sum. Okay, so our sum is going to be, as we said, a sub 1 over 1 minus r. And let's sketch the graph of the rational function here. So I know that this is going to have a vertical asymptote when x is equal to 1/3. So at x is equal to 1/3, I know that as x gets close to 1/3 from the left, this is going to give me a, this is going to give me a number that's a little bit less than 1, so this is going to be a positive number on the bottom. I also know if I plug in 0 for x, I'm going to have a 5. So we're going to have something that looks kind of like this. And on the other side, I'm going to have something that looks like this. And I'm just looking at that between negative 1/3 and 1/3. So as far as the domain, this is the only part of the rational function that I'm going to look at. And if I did plug in negative 1/3 into this function, I would have 5 over 1 plus 1, which would be 5/2. So in fact, not that they ask, but the range for this is 5/2 to infinity.